This is Santiago. Santiago is a gaucho who lives and works on the Chaco Plain in northern Argentina. This region is becoming drier because of a changing climate. 10 years ago, Santiago sought land closer to a river so that more water would be available for his livestock. He wanted to purchase a parcel of land on the floodplain south of the Rio Bermejo, near the village of Oran. This is in the Salta province of Argentina, just east of the Andes. The Rio Bermejo is a meandering river that flows over a distance of 1,000 kilometers, delivering water from the mountains to more than 1.5 million people that inhabit its drainage basin. Although this river has been draining the Andes for thousands of years, its channel is unstable. Seasonal changes in the water and sediment dynamics and long-term tectonic change cause the riverbanks to erode very rapidly. In the summer, water flows can exceed 1,500 cubic meters per second. Evidence of floodplain erosion can be witnessed every day as blocks of sediment detach from the riverbanks. Santiago was worried about buying land so close to the river, so he sought help from geoscientists to determine if he would lose valuable property due to this erosion. By studying characteristics of the modern river channel and its paleochannels, geoscientists can predict where the river will migrate in the future, and we can also calculate the rates at which it migrates. Based on the flow dynamics in the river channel, we can determine which side of the active channel will erode and which side will be stable. Because energy carried by the river water is driven toward the outside of the meander bends, we know that the inside edges of these bends will be stable, but the outside edges will be eroded very quickly. Aerial and satellite imagery are powerful tools for geomorphic analysis. By analyzing images of the Rio Bermejo, we can determine how the river has changed through time. When the river channel migrates, it deposits sediment in its previous path. Radioactive isotopes accumulate in the sediment after it is deposited. Because we know the rate at which these radioactive isotopes are generated, we can calculate the amount of time that has passed since the sediment was deposited. This time tells us how long the channel took to migrate to its current position, thus giving us a migration rate. We determined that the land that Santiago wanted to buy was eroding at a rate of 20 to 30 meters per year. This means that within 10 years, the river would carve out 200 to 300 meters of his property along the river. Due to these high erosion rates, we advise that Santiago not buy that parcel of land. We recommended that he should buy the land on the north bank of the river instead. River systems are dynamic, and our work to understand river dynamics is ongoing. The more data we collect on different types of rivers, the better we can understand the stability of river floodplains.